Now, I'm calling the function again, 3 times factorial of 2, right? This is the same as just fact of fact 2, right? X minus 1, okay? And now, we don't know what this function is. It has to go into that function, right? So we call factorial of 2, right? And we go here, okay, it's not x, and then we don't know what fact 2 is, so we go down and fact 2 is called, and we calculate 2 by fact of 1, right? So we go fact of 1. When it goes down, fact of 0, wait, are we on 2? We go fact of 1, fact of 1 is called, and we return 1, okay? So now we're not returning on a call of a function, we turn 1, and now we go back up the function, where now we know what 1 is. We know that when x is 1, we return 1. So this returns as 1, and then when we called 2, or yeah, it would be 2 times 2 minus 1. So then we would return this as 1, right? Because it's 1, and we get 2 times 1, and now we know what 2 is, right? Now we know what happens when we return that function of 2. So now we have 3. This is when I called 3 times 3 minus 1, right? Because that's when I called function of 2. So now we know what 3 times 2 is, or we know that the output of it is 2, and we multiply that by 3, and that's how we get our final return statement of 6. Was that cool? Hi, honey. Still don't think Amzark understands how it works. Good night, Annie. I love you too. Smiling. Sweet dreams. I would understand this easier, but this involves a lot of plugin stuff that usually confuses me. Alright, I got you. Real quick, alright? Are you ready? Okay. So we have our function. So let's say we put in 3, okay? Now 3, here's my function. Okay, here's my function. And I get, if 1 is 1, return 1, right? Otherwise, we call the function, okay? We call the function on x minus 1. Okay? So I have 3. I put 3 into my function. Yeah? So I have my function, f of 3. And then I call, in this function, I call f of 2. And then in that function, I call f of 1. Now I have to return it, right? So on f of 3, right, I have basically 3 times f of 2, and then 2 times f of 1, right? But we have to return them. We return, right? Return. When we return, we don't know what f of 2 is, right? So when we step into f of 2, we go the function of 2 here, and then I go in, and I'm actually calling f of 2 minus 1, right? So then I have to call into this function, and then when I call into that function, I realize, okay, we return 1, okay? So now this becomes 1. So now we step back up. Now this becomes 1, right? So now we get 2 times 1. So now I know what this function is, and I return this back up to 2 times 1, which gives me 2, right? So now I know what this function, now I know what this equals, so I get 3 times 2, and I return that from this function, which is the original function I gave it, and now I get 6. Does that make sense? Here, I'll do it for 5. Actually, I'll do it for 4. Okay. Well, we just add another step, right? No. Fuck, no we don't. It's not just another step. This is a lot more. Alright, one more time, okay? It's the finding the y, then executing it to find the whole. So what you're saying is I'm under arrest? Honey, do you want to hear me explain a recursion? Was that an okay? Okay, haha. Yo, it's good, Amzert. You actually paid for WinRoad? That's nuts. Translate this to logic like math thinking. Okay. Okay, you ready? So the function of x is the function of y, is the function of z, is the function of a. I should have said b, a, b, c, d. So the function of a times the function of b times the function of c times the function of d. Okay? Okay? Now the function of 3 or no, okay, so let's say a is 4. Okay? A is 4. So I called the function on 4. Now the function has to know what the function of b is. Right? So we call that function where b is 3, right? B is 3, C is 2, D is 1, right? So I call 4 on the function, and we don't know what this function is yet, so we have to call 3, and we don't know what 3 is yet, so we have to call 2, and we don't know what 2 is yet, so we have to call 1, and now we return 1, so now we can return this back into 1, and then we return this back into 2, and then we can return this back into 3, and then we can return this back into 4. This is 3. What the shit? I ain't no touching this shit, homie. Honey, no, it's still typing when I'm not touching it. I think I can go simpler. It's more about the return. The thing about it is about what we're returning, because you have to. It doesn't return until until that function gets returned, right? So it steps all the way down into 1, right? So we step all the way down into 1. Now 1 can return something. Now we've returned a function of c and function of b and function of a. Now we have to return 2, right? The function of c is the same as 2 times the function of 1. And we know that the function of 1 equals 1. So now we get 2 times 1. So now we know the function of c. Now we know the function of c is 2. So now we can go into the function of b, where the function of b is equal to x, which is 3, right? We get 3 times the function of c, and we know the function of fucking c is 2, right? So now we get 3 times 2, okay? And that gives us 6. So now we know the function of b, and then we go to the function of a, where the function of a is x, which is x is 4, which is what we started with here. And then we multiply that by the function of b, and because we know what the function of b now is, which is 6, we can multiply 4 times 6. Fuck, is that right? And now we get 4 times 6 gives me 24, and then I return that because we're out of the loop, right? So now I return that, and that's my answer. Just making sure, dog. Shit, dog. Fuck, dude. That cool? Do you get recursion now? Do you understand why this goes 2 times 6 times 2 times 24 times 2 times 6 times 2? Because what all this is doing is printing it, right? Instead of returning it. So I get x. So I call 4, right? But I don't know what this is yet. I don't know what this function is. Right? It's the same thing. This, what I'm printing here is exactly what I'm returning here. Right? So we go all the way down to the base case. Now I've returned 2. Now I return 6. Now I return 2. Wait, what? I'm confused now. Yeah? Should I mute? Good night, honey. I love you, haha. Amzerk says bye. Yay. Is that cool? So put in 1,000. How long do you think that'll take to run? Damn, we got max recursion too. Why would I ever use recursion? This shit looks so not. This shit just looks so not good in terms of time. Do you know how many times I have to call this function? I think it's broken. Anyways. Okay, I'm gonna do my thing now. Oh, should I rewrite my code iteratively? Oh yeah, I forgot to say everything that you can write recursively, you can write iteratively. If possible, of course, GL with that info. What info? Oh, Horizon. Everything that you can write recursively, you can write iteratively. Just so you know. Yes, if you can write the function recursively, you can 100% always write it iteratively. Iteratively is define func. Okay. Is it like that? Is that how you do that? Okay. And then what do we have? What was it before? I forget. Oh, I have to take in my num, okay? I've taken my number, right? So let's say my number can be num times num times what would it be? Num times I, and then we can say for I in num. Is that how you say it? For I in range of num, something like that. Yeah. Is that right? So it's just a for loop, right? And we'll say factorial equals num plus I. Okay? Do I have to plus it? I forget. I don't, right? And I can return factorial. Right? And I can say num is 3. And we can print factorial of 3. Let's say func of num is factorial. Cool, looks good. Oops. Shit, invalid syntax? Where? Shit, is that not right? I think it's plus equals if you do the factorial thing. Plus plus or plus equals do. Plus equals adds it by 1. Plus plus does the same thing. Oh, I have to take the factorial. I forgot. I have to take the factorial and I have to multiply it by... Oh, fuck. Right, I have to multiply it by itself. Can you? You can probably do times equals. Is that something you can do? For I in range of num. I've done this wrong. We have to do something about range. My range Python doesn't work. Something in range. Python range for n in x, range of 6. It's a sequence of numbers. Create a sequence of numbers. Well, we don't want to start at 1, right? Because we know 1. My invalid syntax, dude. I don't know how to for I in range of this shit. Is there no... Is it the parentheses or like what's good? Like what? Ah, shit. Reference before the assignment. Oh, that's right. Factorial is num. Okay? Factorial is 6. Okay? So, okay, what plus plus does... Alright, hold on. Let me explain to you what plus plus does. So, if I say factorial plus plus, that's the same as saying factorial... God damn it. If I say plus 1, okay? If I say fact plus plus, right, this is the same as saying... Oh my god, am I on over? How the fuck do I get off over? Damn it. Insert? Is it insert? Okay, cool. Okay. Now what times equals does... Okay, this is the same thing, right? Fact is plus 1. Fact plus 1, right? Now, what times equals does, right? Fact times equals... and then let's say I. This is the same as saying... This is the same as saying factorial, which is what I have, times I, right? Does that make sense? So if I said this is 2, I get factorial times 2. Okay? So if I say fact let's see, if I say fact plus equals 1, or let's say plus equals 2, that's the same as saying fact plus 2, and assigning it to factorial, okay? That's basically saying fact is fact plus 2. So fact plus equals 2 is the same as fact plus 2, right? Fact times equals 2 is the same as fact, which is the same as fact equals fact times 2. If I say fact plus plus, it's the same as fact plus 1. So I'd say fact equals plus 1, right? Cool. So does this function make sense to you? Because this is the exact same thing as factorial as a recursion, but easier and probably less shitty. So I take my number 3, I call the function 3, right? I set it equal to factorial. I say for I in range, starting from 2 to 3, right? My in range function, where the first letter starts from that letter. We don't need to start at 1, because 1 times 1 is 1. Alright, so we start at 3. And then we can go all the way, the for loop loops all the way until we get to that number. So I starts at 2, we multiply factorial, which is 3, and I get 3 times 2, and now num is 3, so now I is 3, but we don't need to go into 3. Like it's an exclusive kind of 3, right? We go up to 5. I'm pretty sure, something like that. Right? So range, if we go range 6, it goes 0 to 5. So that's why we don't need to start from 0, we don't need to start from 1, we start from 2, we go up to 3, we don't go into the loop when it is 3, because it's basically saying for I is less than num, right? For I is less than num. This is the same thing, right? So we say I starts at 2, I starts at 2, and num is 3. So we only have to loop it once, and we know that factorial is 2, or factorial is 3, and we can just multiply that by 2. Alright. So we go here. So when I make num 4, right? Num is here, we set factorial to 4, so now this is 4. And we say from 2 to 4, so we would be looping when I is less than 4, right? So we'd start from 2 when I starts at 2, right? I is less than 4, I starts at 2, so we iterate 2 is less than 4, so we go in, right? And then 3 is less than 4, 3 is less than 4, so we go in, and 4 is not less than 4, so then we stop and we go to return. Okay, so now this, and that's so we've looped once and twice. No, I haven't done anything yet. This is just syntax. 2, 4. This is I'm just showing you how this is all just a comment. This isn't code or anything. I don't know what your carrots of 4 are doing, but I'm just showing you how this for loop works, right? We're saying for I in range of 2 to 4. So I starts at 2. We've established that I starts at 2 from this range syntax, right? It tells me like this is how it works. It goes start, stop, and step. Your step is automatically 1. So I could say basically 2 or comma 2. And now when I'm stepping, what they mean by step, right? An integer number specifying the incrementation, right? So if I say 2 now, we start at 2, and then after the first loop, it adds 2 to I. And because we start at 2 and we add another 2 here, we get to 4. And so then we don't run it again because 4 is not less than 4. So we can basically just say this, if we can, oh fuck, I hit insert again, right? This is the same thing. So we have 2, right? We start at 2. Our stop is at 4. and we're stepping over with an increment of 1, which is defaulted, which you don't have to write, but I'll write it here anyway. So we run this twice, right? We run the for loop twice, and my num is 4, so we start this at 4. So factorial is 4. We say, so factorial is 4, and we multiply that by I, and I starts at 2, right? So if I starts at 2, I get 4 times 2, and now that gives me 8, right? And we loop it up again, and we go from 3 to 4, so then we get 8 times 3. Okay? And that gives me 24. And we would technically increment one more time to 4 and realize that, okay, we're at the end. We're not less than 4, so we stop, right? So we go out of the loop and we return. And we return factorial, and factorial is 24 because we assigned that it was originally 8, and then we assigned it to I times 8, and we have 24, right? Cool? Does that make sense? This is iteration, by the way. Iteration is the use of a loop construct like a while loop, for loop, etc. in order to solve a problem, whereas recursion is the use of a function that calls itself to solve a problem. Cool? Okay. Cool. And any problem that can be solved recursively can also be solved through the use of iteration. So yeah, you can understand it, it makes sense, but I wouldn't know what to write for those statements or line of code.